Good morning, everyone. And today we are going to start with the second chapter in physics, that is motion. The purpose of this presentation is to introduce you to the concept of motion, how rest and motion are related to each other, and finally the types of motion. Well, let me begin by explaining rest and motion. When we look around our surroundings, we see many objects. Most of these things, such as windows, doors, they don't appear to move. They simply called stationary objects or are said to be at rest. On the other hand, in our day-to-day life, we come across various objects moving around us. Let us take the example of a man walking on a road, girls dancing, boys playing football, and many more. What are these people actually doing? What is common in all these cases? The first point is all these objects are in motion. That is quite obvious. And the second point is every moving object keeps changing its position continuously. Now we can very easily define these terms, both the terms rest and motion. Rest simply means an object not changing its position with respect to surrounding, while motion means an object changing its position with respect to surrounding in a given time. To put in simple words, motion is change in position with respect to time. Now let's try to understand how rest and motion are relative terms. It simply means an object can be in motion relative to one set of objects, while at rest relative to another set of objects. Let's try to understand this by assuming that you're sitting in a moving car. So you are in motion in relation to the people standing outside. Maybe there's a man standing outside waiting for a bus, or some boy sitting on a bench. With respect to these people, your position is changing. That's why you are in motion. However, if you compare your position, yourself, with respect to the things inside the car, like the driver, your parent, maybe the roof of the car, it's not changing. That means in relation to these objects, you are at rest. So an object can be in motion in relation to one set of objects, while the same object is at rest in relation to another set of objects. It simply means it's the observer and the surrounding that decides whether a given object is at rest or motion. And by this we conclude that yes, rest and motion are relative terms. They are related to each other. I would now like to move to the next part of my presentation that deals with the types of motion. As you all are aware of the fact that objects in our surrounding, they move in various ways. So let's try to understand all these types one by one. The first one is translatory motion. Let me first of all define it. If an object moves in line in such a way that every point of the object moves through the same distance in the same time, then the motion of the object is called translatory motion. Suppose a car is moving on a straight road. The motion of the car is said to be translatory motion. Or we can give the example of an apple falling from tree or a man walking on a road. These all are the examples of translatory motion. To put it more simply, it is the motion in which all points of a moving body move uniformly in the same line or direction. Now translatory motion can be of two types. The first one is rectilinear and the other one is curvilinear. Let's try to understand what exactly rectilinear and curvilinear motion is. Did you notice the term line in here? It simply means the motion of a body along a straight line. For example, a person jogging on a straight road, a car moving on a straight road, and a very good example, when you play carom, a carom coin moving over the carom board. In all these cases, the body is moving along a straight line. Now the next type of motion, that is curvilinear motion. Curvilinear motion is a type of translatory motion. As the name suggests, it is the motion of a body along a curved path. Imagine some children are playing with a ball. When the ball is thrown in air, the ball does not take a straight line path. Rather, the ball moves on a curved path. This motion of the ball is known as curvilinear motion. There are more examples, like the motion of a cycle when you take a turn on a curved path, and a ball thrown by an athlete in a curve. These all are the motions or examples of curvilinear motion. Now this leads me to my next type, that is rotatory motion. A body is said to be in a rotatory motion if it moves about a fixed axis. While looking at cycles and cars, we notice that the tires are moving and their motion is along a fixed axis. This type of motion is known as rotatory motion, where the object is moving about a fixed axis. There are some other examples like blades of a fan, a spinning top, and a merry-go-round. In all these cases, there's a rotation about a fixed axis. And there's one more example of rotatory motion, the rotation of a planet Earth, which is rotating about its own axis. Now let's try to understand the next type, that is oscillatory motion, with the help of an activity which you all can experiment at home. You tie a stone to one end of a string. Now hold the string in one hand and let the stone hang from it. The moment you let it go, you will notice the to and fro motion of the stone about its mean position. So this movement of the stone about its mean position is known as oscillatory motion. So whenever a body moves to and fro about the mean position, the motion of the body is known as oscillatory motion. Now what is special here, that the entire object, the entire body moves to and fro. There are more examples like motion of a swing when you are on a swing and the pendulum of a clock. These all motions come under oscillatory motion. The next type is vibratory motion. It is also an oscillatory motion, but with a difference. In vibratory motion, a part of the body always remains fixed and the rest part moves to and fro about its mean position. To understand vibratory motion better, you can perform an activity at home. You take a wire and stretch it between two fixed points. As the wire is plugged, the wire starts moving to and fro. That means the wire executes vibratory motion. There are some other examples also. All the musical instruments, guitar, sitar, they all execute vibratory motion when they are plugged or played. Now this brings me to the end of my presentation today. In this session we discussed how important motion is in our life and all the types of motion. You can see there are some questions on the screen. You may use the content explained to you in this video to write the answers in your subject notebook, that means your physics notebook. And I hope that this session has been informative. Thank you.